Hello, hello. How are you doing, guys? Got the little one here. She's kind of behaving herself. Purring like crazy. If you can hear. Anyway, she might behave herself. Look at me with my little cat. I expect you to die, Mr. Bond. Let's get the angle on the old kitty. There she is. What a sweetheart. Look at her there. Oh. This is how you up your subscriber list. Get your kitten. Get yourself a kitten. She's a sleepy one. She's half asleep. She wants to play with the headphone cable, but she's a bit too sleepy. Anyway, I think we might have some technical situations. Yeah, got some biological ones as well, because she's biting my arm. Can't hear you, mate. Sorry, just a second. Right, I'm just trying to set up with Andy. We'll just mess about here and set stuff up and give people a chance to arrive. Or whatever, the small handful of people that do come. Let me just have a look at the thing. My mic is working. I need to do some sort of a switch on the audio. Can you hear me? Oh, hang on. Output device. Okay, go ahead.
Can you hear me?
Yeah, I can hear you now. Can you hear me?
Yeah.
We're all good to go. No technical problems at all. Oh, I shouldn't have said that. Right, just a second. I think if I pop that window out, it'll go live. It should. Yeah, I think something's happening. There you are. Jolly good. Don't know what's happening to Dom. Sir Dom. Dom the Don. He might not be about. I didn't remind him. I probably should have. So, there's you and me. And there's two other people. Who's there? Speak out. Say hello. Make yourself known. Yeah, I'm keeping her in here now. The cat, by the way. Did you see her then on the stream? I don't know if you saw her, but. Can you hear me, Andy? Yeah. Can't hear you. Yeah. Sorry. Yeah, I'm keeping her in here just to see, because she just gets very meowly. Take the bin out. Well, there were two things. One, she was going for my headphone cable, right? So I've put it under the shirt, right? And that seems to work. So that was one thing. And the other thing is she figured out how to get around the curtain and into the back of the wiring. But I've blocked that off now. So, you know, she just likes to know I'm here and I think she just feels safer, you know.
Yeah, they love to go where you don't want them to go.
Yeah. Yeah, they do, where they can't go. They've got like a fear of missing out. Oh, I need to go there. If I can't go there, it must be important. Anyway, if she becomes too much of a pest, I'll have to deal with that. But I think it's all right, yes. Hello, Dave. Is that Dave Sapphire? Is that you, sir? You rascal. or somebody else? Imagine it is, because I just told him that I was going live and I haven't got any other friends. Okay. So you haven't played that game, am I right?
I had about, hold on. Yeah, I had about 10, 15 minutes on it.
Okay, oh good. And is there a walkthrough so that you could get somewhere? Because I know you can't get anywhere in games if you don't have a walkthrough.
Well, I got to level 6.
And then it crashed.
And then I got stuck. Because to be honest, well, we'll get into the review in a minute. But
hello, Tiama, welcome. So, yeah, well, I don't know if Dom's come in or not, if he's turning up. I suspect he might not because I didn't remind him. He's probably got better things to do. Yeah, so let's talk about Japanese culture, right? Japanese culture, big, because that's going to be the homebrew that we're looking at. So it's sort of Japanese influenced thing, isn't it? So big influence on gaming, of course, in general.
Very.
If you were to choose your favorite games of all time, what percentage do you think would be from Japan? Because for me,
most of them,
nearly all of them.
Because right? I think most arcade games came from Japan.
Yeah, exactly. I mean, in the early 80s, I mean, I love the old golden age of arcading, I guess they call it.
Yeah.
But the the sort of 81, 82, 3 period. And that was a mix of Japanese and American, really. Because I mean, obviously, you've got things like Asteroids and Robotron and Defender. Those are all like sort of seminal American arcade games. Great,
really good games.
And then obviously on the flip side, you've got the Pac-Man and DK and all of those as well. So yeah, but I think on balance, probably, well, the American titles just kind of faded a little bit, didn't they? It's hard to think of a decent. I mean, I suppose the only American arcade game that I can think of sort of post the mid 80s is probably something like Mortal Kombat or something, right? Trying to think of others, really. I mean, I suppose, even things like the things like Simpsons and Ninja Turtles, they were Japanese developed, right? I think so.
So.
I'm thinking that those kind of things are very ostensibly very American franchises, but nevertheless made by Japanese devs. They've always had the touch, haven't they, really, the Japanese, with the games?
They have.
It's interesting. What's that? Japanese folklore. Have you played any games revolving around Japanese folklore?
Don't think so.
I mean, obviously, there's a few games. I was going to say, because, I don't know. As far as at the time when the Specky was out, I think we were probably more familiar with Chinese folklore, things like Monkey, right?
Yeah.
Or Water Margin and stuff like that. I mean, Monkey was actually a Japanese TV show, but it was based on Chinese folklore, based on the Journey to the West, Sun Wukong and all that. So yeah, I mean, I suppose there would be like samurai games or karate games. I suppose that's a little bit of it, isn't it? But
yeah, what sort of like Way of the Exploding Fist and all that sort of stuff was.
Yeah, well, our knowledge of our knowledge of Born from an Egg on the Mountaintop. Yes, the monkiest monkey. that ever was, right? He knew every magic spell under the sun. Teased the gods, something for everyone. Yeah, I always remember the theme tune at the end. You know, the Gandhara. Do you remember that? Gandhara, Gandhara. They say it was in India. Anyway, have you played any games based on Monkey? There's loads of them, isn't there? Right? I mean, they're in China. There's like a game Son. I think that's based on Monkey.
Yeah, I don't think I've ever seen any, to be honest.
Well, the arcade game Son, right? I'm pretty sure it's quite a fun game, and I'm just checking now. Yeah, if you check it out, I think it's loosely based on the Chinese novel Journey to the West, and he's a monkey boy, and he fights Scree. Yeah, it's quite a fun game actually. It's not bad. He sort of floats on his cloud, and he shoots enemies from left to right, something like that. True. And it was. Yeah. Just a second, guys. I just want to invite my pal to come on. There we go. Right. So yeah, Son is the first one I can think of that was based on it. Did you play there's an Xbox 360 game, sort of with a kind of futuristic cyberpunk version of Journey to the West? Did you play that? It's a really good game. I completed it actually.
Yes. What was that called?
Enslaved, it was called.
Yes, I did.
Enslaved Journey to the West. Yeah.
Yeah, I never finished it.
No, I finished it. Yeah, really good.
Yeah.
Interesting, that one, because it was written by, partially written by Alex Garland, you know, who wrote that book, The Beach.
Right.
And a couple of other books. He's quite a well-known script writer. I think he might have written the script for. Remember we talked about that Judge Dredd film? Did we mention? I think we mentioned that Judge Dredd film. Maybe you weren't here. I think I might have talked to Dom about it. Have you seen that film, Dredd? 2012 it is. I'm just checking. Really enjoyed it actually, and it was written and produced by Alex Garland. There you go. Look at that.
Okay.
I enjoyed that actually. I thought it was half decent, to be honest.
That's weird. From The Boys, that version.
Sorry?
Is that the one with the bloke from The Boys?
To be honest, I haven't watched The Boys, but it's Carl Urban. You know, he's
Carl Urban. Yeah.
Yeah. Is he in The Boys? Is he?
Yeah.
Okay, I just know him from he was in Star Trek, wasn't he?
Yeah.
So yeah, that one. It's all set in like one building and stuff.
Yeah,
it's pretty good. But anyway, of course, the other thing, and we'll kind of segue into the game here, but that Japanese do ghost stories really well, don't they? You know, like films, so scary.
The Grudge is one of my all-time scary films.
Yeah. My favourite is House. Have you ever seen that?
Maybe.
It's not an American... There's an American film called House, right? And then there's a Japanese film called House, yeah? And it's an absolutely mental film, but it is just really, really good. It's just pure entertainment, really. Just the director of that film was, and again, I might have mentioned this before because Dom and I were talking about horror films and stuff on the previous
Yeah.
one. So, but anyway, the director of that film was he was his first film, and before that he'd produced a lot of commercials.
Right.
So he had a kind of eye for making those, and he brought some of that into the film. And the film is just mad because it's a real sort of pastiche of different movies and genres.
Yeah.
Like at one point, it's just like all these schoolgirls walking along singing songs, and then there'll be like some guy in a military suit on a horse, and then the next thing you know, it's like blood spurting out of the walls, and like a mad cat and all this kind of. It's absolutely you got to see the. I mean, to be honest, the trailer has a few spoilers, right?
Yeah.
But it's just I can't recommend it enough. Really, if depends on what you like. But if you like sort of really kind of quirky, daft Japanese horror with like just when you're watching it, you just have no idea what's going to happen next. Then I would say it's one of my favorite films. Actually, it's just really, it just hits all the spots for me. I'll send you the trailer there. You can watch it on.
Yeah.
Have I just sent it to you there, or have I?
Yeah, I think so. Yeah.
Yeah. Yeah. Feel free to give that a little watch. It's only a minute or two.
Okay.
It's super. Yeah, absolutely brilliant. I have to watch it again. I'm sure there are loads of things in it that are that I missed,
Yeah.
And not a ghost story, but also Audition. Have you seen Audition?
I haven't, but I've heard of, and yeah, I just need to get around to, or I need to find a copy.
Well, try not to read too much about it. Do you know much about it?
I know it's gruesome.
Yeah. Well, what kind of the thing that kind of gets you is that it starts out so kind of banal, and it just seems like a fairly normal film, and then it's like you're just driving along a country road, and then all of a sudden, the driver, the director, just smashes you off the road and straight into the forest, and he never lets up from then on,
Right.
So it's
okay.
Yeah, it's worth it for that, right? So anyway, this game that we're looking at is I'm gonna have to get so this is by a guy who I actually know quite well, actually. Well, I mean, I don't know him personally. I only chatted on Facebook, but his name's Ariel Andoras. I think he's from Argentina, actually. I might be wrong there. Is he from Argentina?
I think so, yeah.
Yeah, so, South America is a little hideaway for Spectrum. We've had a couple of Brazilian games, but it wasn't huge. I think, maybe there was the Portuguese Spectrum maybe went to Brazil. I don't know about, and maybe the Spanish one went to Argentina. That's possible, isn't it? I don't think there was a big scene over there.
Yeah.
But anyway, he's made quite a few. I think he's made 4 or 5 games. He's done that game Vampire Vengeance, where you play as a kind of Nosferatu type character and you drink the blood of your enemies and stuff. That's not bad. And another one, I think it's called Robot Rumble or something. They're AGD games, but he does try, like you do. He tries to do things a little bit differently and make something that's not just like a fetch quest or whatever. Sorry about that, guys. I just started the game off without. While I was still speaking about it, but yeah. Okay, so I don't need this window. What's that window? That's the chat video, isn't it? We'll take that one away. And let's see. Not very good at this, really. Right, hang on. Add a window. That's weird. That's Spectaculator.
What is?
The thing that, you know, the where I've posted there about you see on the, I don't know if you can see it on the stream, but it's coming up as the chat window of Discord, right?
Yeah.
See where I've posted that for you there when I was just like,
yeah.
But that's actually Spectaculator. And now, okay, now it's okay. There must be something to do with the window capture when you're on pause or something, right?
Yeah.
There you go. It's a good job we weren't slagging anyone off in the old Discord there, wasn't it? We don't do that. Anyway, so Andy, I haven't played it. I've decided that you're the one that's going to play the games, and then I'm going to play them. I'll be like playing them for the first time, and then you give me some tips. Look, I've got a credit there. Look at that. Look at me. I've got a credit. Look.
Oh yeah.
Yeah. It's always nice to get a credit, you know.
Yep.
People don't always do that, but you know, it's nice when they do.
Yep.
And I'm not receiving any kickbacks or anything like that, by the way. Happy to just give this a review because it's just come out, and Ariel's a good bloke, and he's made some pretty nice games. And so, yeah, I mean, I think, well, you and I were talking about this earlier, Andy, and sometimes, you know, we look on the old Indie Retro News, or we look on the Spectrum Computing, look for games that are announced, you know.
Yeah.
And then you sort of see the clips or something, and you think, oh, it's another AGD fetch game, run around, find stuff, bring it back, you know.
Yeah.
Another one of those blokes who finally get to make their own game and release it, sort of thing, and great, good for them, but nothing too exciting, really. But this one, and I'll be honest, when I first saw the screenshots, I suspected that that's what it was, but then once I saw it a little bit more, I realised it wasn't.
Yeah.
And to be honest, at the time I didn't know that it was written by Ariel, and if I'd known that, then I would have expected it to have been a little bit more interesting than that, and it is, right? So what can you tell us about this one then? Did you like it?
Did I like it? It's, as you say, it's different from a normal AGD game. You're not picking stuff up. It's not a flip screen of roam around and platformer. There are obviously platform sort of parts of the game, but each screen is self-contained.
So you have to solve it, right? Like to get
you've got like tasks that you have to do with various creatures around the level that you as a spirit can go and inhabit.
Right. Well, yeah, I was going to say, do you know what a yokai is?
No, I guess it's some sort of spirit, some sort.
Laura, the kind of the translation of yokai apparently is something like strange, mysterious, mischievous thing, you know.
Okay.
Like a sort of spirit or a poltergeist or some sort of entity, you know.
Okay.
But difficult to translate it directly.
Mm.
But yeah, I guess that would explain the We got music credits there. Can't see it. Oh yeah, Mr. Rancid.
Yeah, there is.
Mr. Rancid.
Mr. Rancid.
All right, Mr. Rancid. Good work. I quite like this one. Let's have a listen. It's got a feel.
Yeah, I mean the intro music is quite cool.
Yeah. Let's give it a listen in a second.
I mind you, I'm muted on the stream.
So yeah, that's got that classic Japanese feel, feel to it. You know that pitch bend. Sometimes it's a little bit overdone on the old AY, but in this case it works because it kind of suits the style of the music and everything. So yeah, quite nice. So in this game you play as are you actually like a sort of wandering spirit? Is that the idea?
Believe so. I haven't really read the blurb that comes with it. But I guess you're helping the monk or Buddha reach the next level.
I see. So there are two characters then.
Yes. So you kind of have to go through the level, and this is kind of where things started to get a little bit confusing for me. I didn't really get what I was doing. I'd watched a video, and so I knew that, like on the first levels, you basically just have to kill the creepy crawlies. And then that opened a gate, and then you could control the Buddha to get into the next level. But as the levels progressed, I wasn't really sure. I was finishing the levels, but I didn't really get why.
I see. All right, so basically, you're this ghost, right?
Yeah.
And being a ghost, you can move to anywhere on the screen, right? Which is nice.
Yes.
Apart from the mystery walls at the sides, but yeah, fair enough.
Yeah.
Limitation, right? Okay, well that's kind of cool in the fact that you can just go anywhere. Yeah. And it's one of those occasions where the old, the way that it prints, with the XOR.
Yeah.
It kind of helps in a way because it gives you that kind of ghostly shimmer as you pass through. I'm being kind there, but it does. All right, so we've got to get him out, right? So presumably
you've got to get the yellow guy out,
right? So
but he can't go past that pink stone.
Okay. So what have I got to do with this little creature then? I've got to...
So you have to kill him. There's some spikes just below you if you have a look at that wall.
Ah, I see. Right there, yeah.
So, yeah, literally just go and squish him, and then you do the next one.
Okay, so this is just a level to explain how it works, right? Oh, you can get out again.
Yeah, for these particular creatures, yeah.
What happened to me? What happened then?
Yeah, it's you can pop. Now, see that?
Yeah.
That happened to me.
I pressed down to get out of the ghost of the creature, right?
Yeah.
And it kind of, what did it do? Kind of popped me to a place that wasn't there. Look, it just happened again. What did I do then? That's a bit buggy, isn't it? What's going on there?
Right. Yeah.
How?
But that happened to me on level 6, and then it took me back to it restarted the game.
I see. Yeah, that's
so
good,
I think
all right.
A little more testing and some debugging needs to happen.
Seems like it, yeah. Well, it's very important, guys, to understand. Can I take possession of the Buddha then, right?
You can.
So
now, yes.
Yeah, playtesting is very important, guys. We can't stress it enough.
Yeah.
And it's, I mean,
for my games, I get people on like months before.
Yeah. Well, part of the reason that we started doing this, isn't it, was to play. Yeah, you see, look, I mean, what's going on there? I don't know. Did I die or I just reappeared or? Okay.
Yeah. But see, you did die then because you lost a spirit.
Oh, did I? Well, that's not good.
Yeah. So I don't know if you can actually finish this level now.
Yeah, I'm confused as to what's going on there.
Yeah. Then this is what happened to me, because I think you've actually got to put the creepy crawly at the bottom onto the button, but I don't know what the buttons do.
Did I just lose another life?
No, you're back to 5 now somehow.
No, it says 3 there now.
Oh, 4 now.
Spirit
3
2.
now.
Is it counting? Is it like a timer? Look, 1. I've got a certain amount of time that I can spend in there.
Okay.
Like I've got a time limit on how much time I can spend inside. Right, so I've got to sort of go in and put him on there and then come out again, right?
Right.
Okay, and then I'll get this guy. Okay, so that's what's been going on. I think it's basically, I mean, it's okay. It probably is in the instructions, but it should be a little more intuitive than that, I would say.
Yeah.
Because I didn't know what was going on.
With the fire.
I've got Spirit 3 now. Yeah. And then go and get this guy with the spikes.
Yeah.
And I've got Spirit 2, Spirit 1. I might not have quite enough. I might run out of spirit here. No, I just made it. Okay.
Yeah.
Yeah, that should be a bit clearer. But then again, hello, Tailser. Then again, read the instructions or whatever. But
yeah. I think
a first level where it was clear,
Yeah.
Little thing that just said you can inhabit the spirits. Right. So I've got 7. And that means I can, that's how much time I've got to inhabit these little creatures, right? So what does let's find out. Oh, I didn't mean to do that, but anyway, I've killed that plant. What does this button do?
See, yeah, I don't know what the buttons do.
Well, I turned off the fire.
Oh, that turns off the fire.
Oh, okay. So maybe you need to turn off the fire to get the Buddha.
Yeah, so the plant will eat the creepy crawlies. So maybe you have to put
I see. So
bug on there, get the plant out. Plant eats the creepy crawlies. Leave the plant on the button, or kill the plant with the flame. I don't know. And then that will remove the stone.
Yeah. So
what I'd like to see.
I've messed it up at this point.
Yeah, is just a little bit more polish. It's like
more than a little.
Some like to know that something's dead.
I'd like to know. Can I reset this level? Okay, I just died. Is there a way of just resetting?
I have no idea.
Okay, so. All right, here's my plan, right? I'm going to take this one down here like this.
Yeah.
I'm going to take this one. I'm going to take this one also down here like this. And then do the same with this one. Right. I'm going to put it on there. Yeah. And then I'm going to get the monster plant, right? Who can jump.
Yeah.
Presumably, you say he can eat all of these, right?
Yeah.
What's happened now? That's weird. Oh. But I got to destroy.
So now, if you take him off the button, the flame should come back on, right?
Ah, okay. All right, but I can't get back up. Oh, can I?
Yeah.
Okay.
You got time. That's the thing.
Yeah. Well, you're going to have to, aren't you? Because it won't work otherwise, right? So
I think just take one of them
yeah, I
and put
agree.
it on the button. Leave the other two up there because then it's closer.
Yeah, yeah. Look, we'll eat that one, and then we'll go that way. And we'll eat that one. Yeah, and then we'll eat this one, and then you see that's fiddly, but we're there. Oh, I'm only on spirit one though. I'm going to run out of spirit, aren't I? Or is it the number of times that you can possess, or what? It doesn't.
No, it's going down on a timer.
Okay. Yeah, pretty sure Dom's not joining us.
Yeah.
Just double check. Nope. All right. Okay. Yeah, by the way, the cat, she's just found a little place by the radiator and she's just chill now. So, or not chill, because obviously you don't really chill by the radiator. But... Okay. Is it the same music all the way through?
Yes.
Well, that'd be nice, wouldn't it, to have a different tunes. So it's more of a puzzle game than anything, right?
Yeah. Yeah.
So presumably, I mean, okay. So
You want to get out of that because you don't want to be staying in there very long.
yeah, you know what it's like possessing bodies.
I know. It's a bit addictive, isn't it?
Saps your ectoplasm, doesn't it?
Yeah. So.
Right. Bam. So that turns on both fires then? I mean, do you need... Is it... Okay. So if I'm if I'm eating that one, and then I'm going down here, chomping on this one, but then I won't be able to kill this one, will I? Or will I?
Yeah.
I see.
Although, yeah.
All right. Well, overall, I mean, I think it's not bad. It's not bad. It's not quite my thing. I'm not that into kind of puzzle games myself. I don't know about you, but
I kind of I wanted to like it.
Yeah.
But I wasn't feeling anything when I was playing it, you know? Exactly, tells you. I mean, it's got some, for an AGD game, really different mechanics. So hats off Ariel for that. I think, you've kind of broken the mold on the regular AGD type game.
Yeah. Which he does, with his other games as well.
Absolutely. I mean, the vampire one was great. So, I don't know really why. I think maybe it was just a little confusing. Like if I'd known that at the time that the spirit went down. I mean, kind of what it needs to do is be an obvious timer. I think.
Yeah. Well, going back to what you were saying about the polish, right? If you kind of had a bit more of an intro on this game, right? Give it a bit more character so that you could kind of understand a little bit more about what was going on.
Yeah.
That would help, wouldn't it? and then
Yeah.
that would give you that a little bit of sympathy, and then with the character, I mean, and then also, um, yeah, that was weird because I just didn't understand why I was dying it, or
No.
I thought, what's going on? Have I got 7 lives?
That's it. That's what I thought.
And
And I don't know what the
I know,
side
of course,
for.
everyone can say, well, just read the, RTFM, but nevertheless,
Yeah.
um, when you're playing these old games, you just want to go and just figure it out, don't you? I mean,
Is
it's
it?
it's
I never
it's
noticed
kind of
that.
part of the fun. Hmm? What's that?
As I said, it pops up when you first inhabit. Oh, is that what you're saying? It should do. Yes, absolutely. Yeah.
Yeah, a little message or something, right?
I
So
mean, even if like the numbers, um, I don't know, like for the numbers or the timer, the spirit timer, if that kind of not animated but color cycled or something to show that it was literally going down. I
yeah,
don't know. It needed something to make it
because you've
more
got
obvious
this,
rather than
you see, you've got this intro here, yeah, and
yeah. That doesn't really
it
say
doesn't.
anything
Well,
though.
exactly. So that what you need really is, um, well, to be honest, I mean, presumably what you'd have is like the Buddha and the ghost talking to each other maybe and saying, you must,
Mm,
help me. You need to help me get away. I can't move. I'm trapped, or something.
yeah,
Or you'll have to possess the spirits of the creatures. La di da.
yeah,
I will give you certain number of spirits. But remember, every time that you possess a creature, you will lose your spirit power will
yeah,
diminish. Right? Actually,
yeah,
thinking about it, it's a bit. I mean, it could be something to do with the translation, right? Because obviously this is a non-native English speaker.
yeah,
So
yeah,
when it says, you see, when it says spirit, um, we naturally think of that as kind of countable, right? And obviously there's a number there, right? So you
yeah,
get this impression that, oh, you've got a number of spirits, right?
yes,
Whereas actually what it is, it's more like spirit as in like your power, and it's not
mm,
countable. Yeah.
yeah,
And that's where, as you say, um, an energy bar or something like that
yeah,
would would make a big difference, because as soon as you got into one of those creatures and you saw your little energy bar going like this, you'd be like, oh, okay,
mm,
yeah,
yeah,
and that would be more, the sort of granularity of it would be better as well, wouldn't it? Because
yeah. It would. Yeah,
it just goes 7, 6, and you're like, what's going on? Did I just lose a life?
yeah.
So I would say that would make a huge difference. Would be,
But and also like when you run out of spirit, pause. You know, have a pause. Try again. You know, but it just kind of like instantly restarts.
yeah, yeah. Perhaps he's
Um,
perhaps he's a bit short on memory or something there.
could be. Yeah, absolutely.
Tailser is saying a jar emptying. Well, it could be a jar, but he hasn't got a lot of
Mm,
sort of real estate to do that. I think just a single life bar. I mean, look, obviously it'd be nice if it was something slightly, a little bit fancier, like a wavy line, or
yeah.
you had like little hearts or something on. Was it Nixie 2? Was
Mm,
it? Yeah, something like that. That would be
mm,
nice.
yeah.
Um, and yeah, I mean, I suppose it's fairly obvious what the monsters do, but maybe a little sort of rogues gallery little thing where it says like slimes or whatever they're called.
Yeah.
Uh,
Can't. Yeah.
these eat these and these do that, and because I think it. I mean,
I mean, that's what this screen should be, really.
yeah,
you know, that little intro screen should basically be the different enemies and what they do, what you do with them.
Yeah. Yeah, I think so. I'll tell you one thing. I mean, I've done that. I've done that thing for AGDX where you can save the sprite
Yeah,
memory, right? Well,
yeah,
and it's slightly slower than regular AGD, but not drastically. Well, this obviously would be a massive good candidate for that because
yeah. It would.
there's really only one thing moving at once.
Yeah, yeah. You're right, Telzer. It is part of the enjoyment of it, isn't it?
What's that?
Tells saying, but isn't that part of the fun
yes,
of the puzzler?
that's true, but then that's what we call intuitive, right? That's when something is intuitive, when it's like you can figure it out yourself because it's intuitive.
You need to put the button
Whereas,
on.
oh right, yeah, sorry, I'm just messing about really. But yeah, so it is the fun of a puzzler to work it out, but um, if you do that, it needs to be intuitive, right? The best games, as you say, they don't need instructions because they're intuitive, right? And that is absolutely 100%. If you want to talk about, good game concept and theory, then a
Yeah,
game you should be able to pick the game up and not read the instructions, right?
yeah. Learn it and
And
understand
figure it
what's
out.
going
But
on.
figuring it out
Yeah.
should be intuitive and also a little bit of fun, right?
Hmm.
Because if it needs to be explained to you, if you need to read a manual, then it's too complicated, isn't it? I mean, unless it's like a flight sim or something, in which case, obviously.
Yeah.
But I've never considered reading instructions to be fun,
Mm.
right?
Okay.
I mean,
Yeah.
I'm trying to think of a time when reading instructions is fun, but I can't. Um,
I'll be
well,
back
no,
in
there
30
is there
seconds.
is. Oh, sorry. Yeah, go ahead. Yeah. So, how have you all guys? How have you guys been doing? I can see Tails are obviously manically filling up the old screen. Mitsuyama, you good? Did you guys all? I know last week, right? The I didn't know that the Amigos were also doing a stream, and obviously a few of you guys, the little crowd that we get here, some of you guys go to their stream. I know, and and obviously your loyalty is to them. They've been doing it for ages. I don't begrudge it, but I had no idea that they changed just for that last week. They changed their stream to Thursday, and they sort of started off about an hour after I was streaming, and suddenly everyone disappeared. There was a big drop off. Well, for me, obviously, there's not a lot of people watching anyway, but you guys all went off to join Aaron and John. I think that's what happened. anyway, anyway, it was no problem. I'm sure you caught up with it later. So yeah, um, yeah. Tails is just talking about different games with instructions. I can't think. I mean, unless you're really into like flight simulators and stuff, then
Sorry.
that would be a way. You could kind of get really into it, like a big manual. So yeah. Um, and obviously, if you're doing some coding, right? If you're learning how to program or something, then obviously then it's good to have a manual because otherwise you'd be stuffed, wouldn't you? I guess it's kind of fun sometimes if you do a DIY project with your better half and you're putting some shelves and they read the instructions to you or something like this. Maybe, perhaps that's fun. I don't know. Are you back now, Andy?
Yeah, I'm here. I had to try and get the cat out of the office because she beds in there and won't come out.
Oh, I see. What did you do? Laser pointer?
No, I just shoved her up the arse and she moved off the chair.
I just used the old laser pointer. Point. There you go. Yeah, come out.
I got a little cat toy laser pointer. It sits on the shelf, and every now and then, as they come near, it senses movement, and it throws a laser out.
Just trying to see where she is. I think she's just down the side of the radiator. So. It's ridiculous where they can go. She went under this barrier, like through the. Like a radiator's got like a pipe, and then you got your wall, and then you've got your radiator pipe, yeah.
Yeah.
So she went between there, like squeezed right through. I thought she was going to get stuck, but she didn't. One of these days she will get stuck. I would not be surprised, But anyway, that's why they have whiskers, isn't it? To know where they can how much space they can get through. Yeah.
Yeah.
Yeah. Did you know that? Yeah. The reason they have whiskers is that when they go to a gap, yeah, they feel it with their whiskers, and they know that that's like
the size of their head.
Yeah. The size of the body more. Like they know that if it's tickling the whiskers, it's probably a bit too narrow for them, But they'll still try and squeeze through very tiny gaps anyway. So I'm not sure how much it works. But yeah, they do basically use their whiskers for sort of sensing the environment around them. So. Anyway, yeah, I was just saying maybe like I was trying to think when can be fun reading instructions. The only time I can think of is if you're reading them to someone else and it becomes a bit of a kind of quest or something, right?
Yeah.
But I don't know. Like if I was building a chest of drawers and my wife was reading it out to me or something, it might be fun. I'll tell you something funny. So before I tell you this, I first of all I want to say that my wife is really smart and she's really good in kind of PR and stuff. That's her main thing. She used to work for the United Nations and so on. There's just a caveat here to say that I do think my wife is very intelligent. I said to her though, "Oh, I've got some couple of old desktop computers there." She said, "Oh yeah, I haven't got my own computer. I've just got the work laptop." Yeah.
Yeah.
And I said, "Oh, do you want like a desktop PC?" And she went, "What, like with a processor?" And I said, "Yeah, they do come with a processor." But it sounded funny, right? It sounded funny, but in reality, what then became apparent was that in the Soviet period, when they got these big chunky sort of PCs, yeah, in Russian apparently they just called that processor.
Oh.
Right, like the whole case and the whole thing that's got the motherboard in it and everything. The Russian word for that is processor.
Okay.
Apparently, something like that. So maybe
that makes sense.
But anyway, that's the reason. So she thought, oh, like a processor. What she didn't mean a CPU. She meant a machine, she meant like a desktop machine. So yeah, we often get these little confusions, that make us laugh between the two languages because sometimes it's in language teaching you call it a false friend, like in Russian the word for shop is magazine, like French.
Okay.
So there are different things like that happen. It's pretty funny. I was at the dentist today. I've got to go to the dentist tomorrow. My tooth, I grind my teeth in my sleep, right? And this tooth got chipped and I had to have root canal. But it's actually okay, but it's got worn down and it needs to be restored.
Yeah.
So, but it was quite funny. I was at the dentist, and I can speak Russian, but they also like to speak English. And I was sat there, and she said, "Yeah, have a seat like this." And then she said, "You can give me your clothes if you want."
Right.
And I said, "Oh," I said, "I'll just give you my jacket, not the rest of my clothes, because it's it's the dentist, not the doctor."
Yeah.
And then she looked at me like this, and then she realized what she'd said, and she looked really embarrassed, but then she started laughing. Yeah, I'll take your clothes if you want.
Yeah.
Just the jacket, all right. Just sit there in the dentist in the nuddy layer, oh yeah, just having my teeth looked at, yeah, have an X-ray. Yeah, it's a bit chilly, isn't it?
Yeah.
Anyway, not massively looking forward to it, but I'm all right with the dentist. I don't know about you, but
yeah. I don't get hold of them. Mind you, round here you can't get hold of one. Love my money.
Well, I walked in and she said, "Yeah, we can do it right now if you want."
Not here.
And I said, "All right," but I said, "No, what about tomorrow?" She said, "Yeah, you come tomorrow."
Okay.
But I could have literally just walked in, had it done, and walked out. It would have taken about an hour. But I was having dinner with my wife that night, and I thought, yeah, I don't want anaesthetic while I'm eating my dinner. So, yeah. Anyway, right, I'm going to pop to the loo, and then when we come back, let's talk about coding.
Okie dokie.
All right, back very soon.
Yeah. Oh, that's no problem.
Keep them chatting there, Andy. I don't know how many.
I will. Just grabbing a drink.
Ask a couple of questions. I don't know if you can think of a game that's similar to this, by the way. We usually like to pick out a specky game that's similar, but I don't think there is one. Just going to check on the little cat. You're right. She's down the side of the desk there, resting. She seems to like it. All right.
So on a non-retro related tangent, I picked up a game yesterday on Steam, and it's called Inside, and it's kind of in the vein of Flashback, from, well, I guess what, the late 80s, early 90s. It's got some lovely animation. Yeah, right? It's so atmospheric. Quite like jump scary in places as well. And I'm absolutely, I've literally just, I totally forgot about the stream tonight. I was in the office playing it. Yes, it is. Yeah. I was literally playing it for, I think, about 3.5 hours non-stop. I just couldn't put it down. And then Alan's like, "Have you played the game?" And I'm like, "Oh, shit, no." So I stopped playing it and started playing.
Don't need to put the headphones
Inside.
Cable through my t-shirt now because she's just asleep down there.
So yes, I
what are we talking about?
Recommend a game called Inside on Steam.
Oh yeah, is that a new one or has it been out a while?
I don't know if it's new. I saw a video, like somebody playing it on a stream, just a part of it, and I thought, oh, that looks nice. As I say, it's kind of in the sort of same vein as Flashback and Another World. That sort of animation style. There's no textures. It's all the detail is from objects in the world, and the lighting. The lighting is incredible, and it actually is part of the gameplay later on.
Oh, I see. Yeah, Mitzian
Like
was
you have to
mentioning
stay out of
Limbo, wasn't he?
lights. But yeah, I mean it's only like 10 or 15 quid or something. But I tell you what, I was playing it for 3.5 hours, and if you hadn't have messaged me, I would still be in there playing it. It is absolutely fantastic.
There's
and it's so simple.
there was a side-scrolling zombie game for
Yeah.
the on the 360. Um, I wish I could remember what it was called. Oh, I think is it called Deadlight? No, maybe. Oh yeah, it could be Deadlight. Let me just see. Yeah, have you played? There's a game called Deadlight. If you want to check that out, it's something similar. If you just, I finished that as well. It was pretty good. It was a bit short,
Yeah.
but it was good.
What's it called?
Deadlight.
Deadlight.
Yeah, just Deadlight.
Okay.
Yeah, it's similar, isn't it? I'm
just having a look at a video. Yeah, quite similar actually.
Yeah, that was a good game. Actually.
You play in like the two axes only.
Yeah, it's like a 2.5D or something.
Yeah.
Yeah.
I mean, this looks quite. I mean, obviously, this is highly textured, and
yeah.
So imagine this, but really simplified art.
Yeah, like sort of polygons, like the old Another World or something, rather than
I
flashback.
think that's what drew me to it.
Yeah, you're thinking of Another World, aren't you, more than Flashback?
Yeah.
Yeah, that's a nice art style. Yeah, cool. I haven't been playing much at all, except I've been playing Grand Theft Auto 5 actually for my sins. Yeah, well, it's just to pick up and play. You can just sort of hang out in the city and just drive around and see what there is to find. So yeah, I haven't been playing much. Just been doing a lot of coding, really, trying to get things working with the game so we can have them ready for the event.
Yes, very much so.
Anyway, I've been trying to think what to do today with the old code-wise. I think perhaps we could go back to the plotting pixels thing, because I don't think we ever finished that, did we?
No.
And I don't know if I tell you what though, I mean I don't know where to start with that, to be honest. Just having a look here at we've got simple demo here.
Yeah.
Yeah, there's draw X, draw Y, right? Yeah, that'll be it.
Yeah, I don't know whether you did some with Dom the week I was gone.
No, I didn't. I went back to sort of basics.
Yeah, but I think we had draw X and draw Y, but we never combined them.
Yeah, well, let's try and figure it out.
Yeah.
Let's have a look at this old code and we'll try and figure out what we did. I mean, ultimately, the conclusion that we'll come to is that it's easier to use lookup tables than.
Is it?
Yeah, I mean, it's going to use up more memory, but it's just a million times easier because you see, like have we got this? Let me move the old thing out of the way there. Just a minute. Window. Can't see that. Move that over there. Like all these calculations that you're doing here to figure out which segment that we're in and all that, yeah?
Yeah.
Well, what you do is a lookup table is what you call pre-calc, right? Pre-calculation.
Yeah.
So what you can imagine in 8-bit, so you've got 256 numbers, right? Possible numbers. Yeah.
Yeah.
So therefore, you can do the calculation for all 256 numbers and put the result in as a single byte. If you can do that, then you use 256 bytes only, and you've got every possible result. So then you don't need to look up the answers.
Right.
I mean, let me explain that in a simpler way. We will come back to this, but in principle, let's say, for example, now obviously with something like this, you wouldn't be able to use. Well, let's say you wanted to divide by 3, right?
Yeah.
So for some reason, you were going to be dividing by 3 a lot. So you would be like, okay, well, instead of so we'll start with numbers like this, right? Now, obviously, we're not going to be able to get decimal points, right? But what you do is you'd say, okay, 0 divided by 3, 1 divided by 3, 2 divided by 3, and then it would be like that, 1, yeah?
Yeah.
See what I mean? Something like this. I mean, it's not a very good example, but if you were to store that at a memory address, let's say, for example, and you aligned it to 256, right? So you would, let's say you put here like align 256, right? And let's say, for argument's sake, that it's at address, I don't know, CD00, right? So what you would do is you would store the answers like that, right?
Yeah.
Like that, right?
Yeah.
Okay, so then if you wanted to divide by 3, because the only reason you do this is if you want to do it really quickly, right? But so then what you would do is let's say your value, let's say you want to divide 5 by 3, right?
Yeah.
Obviously without the decimal. So let's say 11 by 3, something like that, right? 11. Yeah. So all you'd have to do is you just go load L 11, load H CD, right? So 11, let's use hexadecimal. So 11 is OB, right?
Mm-hmm.
And then you just go load A HL, right?
Where did you get 0B from?
Sorry?
Where does 0b come
from? That's 11. That's the number we want to divide.
Oh, okay.
Yeah?
Yeah.
So, I mean, what you might do is you might load it from a memory address like this where you've stored it, yeah? And then put it into L like that, yeah?
Yeah.
Right? So what that means is that you can use a 256 byte chunk of data to make a 256 number array, right?
Yeah.
You know, in BASIC, you can have you know how arrays work, yeah?
Yeah. Yeah.
So in BASIC, what effectively that works as is it's like saying CD is the name of the array, and then like that, right? So CD32, that classic console. Do you see what I mean? Because it's a table. Effectively, it's a table.
Yeah.
Where you can, and it's got 256 entries, right? So
yeah.
If you see, look, you see what I mean? Look, all I do is I count from here, and I just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right?
Yeah.
There. So if I set L to that 11, then when I read HL, it's going to give me that number.
Yeah.
So therefore, I know that 3 was it 3? I think so. So it's 0, 1, 2, 3, 4, 9, 10, 11. Yeah, so I know that 11 divided by 3 is going to be, well, 3. 12 divided by 3 would be 4, right?
Yeah.
But you see, I don't have to do any calc. It's just lookup.
Yeah.
Right?
You're just looking at.
And if I had like a few other numbers, you know, like this. Say I wanted to do two different numbers like this, 5 and 11, or let's say 14. Yeah.
Yeah.
Then I would just do this: load LB like this. So I would go load get the lookup table, and then B. So that's 5 divided by 3. Yeah. And then load LC, and then that would be let's say I wanted the answer in D, then I could do it like that, you see?
No, but I am behind because am I supposed to be watching it on
Sorry, I should. It's actually not very laggy today, is it? I've noticed it's quite quick.
Yeah, it is for me.
Okay then. All right, bear with me. Sorry, I forgot about that. Silly me. Okay, you got that now?
Yeah.
All right, so let me explain. So again, just to be clear, this is how you use lookup tables. In fact, we used a lookup table here. Do you remember with this pixel pattern?
Yeah, we did. Yeah.
Right. So it's a similar principle to that. That is a lookup table, but in this case, so lookup tables they can be 256 bytes, or they can be 16 or 32, or they can be anything, right? A jump table is also a lookup table, right?
Yeah.
Where, in fact, yeah, I mean, look, let's look at how you might implement a jump table. Or was this clear to you, this one? Do you want me to explain it slightly more? Or?
Yeah. Could you just go through it one more time?
Yeah. Okay. Right. So I want to know what 5 divided by 3 is and what 14 divided by 3 is, right?
Okay. Right.
So I've got a table that tells me all the answers from 0 to 255 divided by 3. Yeah. So all I have to do is set my low byte to the value that I want the answer for,
Yeah.
and then read the table.
Right.
Because it's just a list, you know?
Yeah.
And
Yeah.
then here, I've set the low byte again, and this time I set it for 14. And so and I'll read it from the table.
Okay.
All right? So it's basically like pre-calculation. So just to show you another example of that, right? This is an easy example. Let's say we wanted to do a jump table, right?
Yeah.
So we're implementing a kind of gravity, and we don't
Yeah.
want it to just be floated. We want it to feel like a jump, right?
Yeah.
So we'll say when the player jumps, then they should go up by, say, I don't know, 4 pixels maybe.
Yeah. Yeah. I did this in Next Basic the other day.
Yeah. So we'll call that you can put -4. It'll actually be stored as 251, I think. Yeah, something like that, right? But you can put -4, and it'll understand what you want it to do. Yeah, and then you'll go like -3, -2.
Yeah.
-1, -1, 0, 0, 1, 1, 2, 3, 4, right?
Yep.
So in this scenario, then we're actually, we'll call that jump table, right?
Yeah.
And then, yeah, you want to make sure that you don't, it doesn't cross a byte line, otherwise it could get, well, it doesn't, if it just saves you, it could save you, could be slightly quicker. It probably doesn't matter really. We can just use
so that's why you align. Yeah.
Well, I could align this one to 8, or I mean, it's more than 8, isn't it? So I could align it to 16, for example, right? And it just means I don't have to do a 16-bit increase. I could just ink L instead of ink HL.
Yeah. Yeah.
But we can do it without that. So let's say we've got, you see we've got there Y pos, right? Y position.
Mm-hmm.
So you'd have something like, well, you'd want to have like a some kind of jump counter as well, right?
Yeah.
So what you might do is you might put the jump table aligned to 256 so that would be 0. And that way you'd know what your jump counter was at any time, right? But it's easy enough to do this, right? So let's go. We put a jump counter in, right?
Yeah.
Now I am going to align this to 16 so that, because it just means that when I add to yeah, well, you'll see in a moment anyway, but it's probably easier to do that. We'll see. So what you would do is, if the player pressed jump, right?
Yeah.
Let's say jump is pressed, right? So then we would probably, okay, so let's say we put the jump counter at 255, right?
Yeah.
And that would mean, and now again, this is all arbitrary really, but we'll put 255. That means that the player is not in the air, right?
Yeah.
So what you would then do is, if jump is pressed, we'd check for a key, yeah? And then we would go something like XOR A, which is the same as load A0, right? It's a shortcut.
Mm-hmm.
So it just sets the accumulator to 0.
Yeah.
And then load jump counter A, right?
Yeah.
And so that means the jump is initialized, right?
Yes.
And then in another part of the code, you would have a test like this, right? In fact, what you would probably do is this. You'd go here, load, and this is what you would actually do, right? You would go load a jump counter, right? Yeah?
Mm-hmm.
When the player presses jump, right?
Yeah.
And I'll explain to you why I'm going to do this, right? Inc A, and then I'm going to go JRZ in jump, right? Yeah, okay, JRZ in there. And I'll put in jump down here somewhere, right? Okay, so just to explain what I'm doing, right? Jump is pressed. So the first thing I'm going to say is player already jumping, right?
Yeah.
So to check if the player's already jumping, we'll look at the jump counter, right?
Yeah.
We'll increase it, and we know that we've set the jump counter to 255, right? That means that the player is not jumping.
Yeah.
So if you increase it, it's going to become 0, right?
0. Yeah.
So what I'm actually doing there is I'm testing to see if it's 255, right?
Yeah.
So, I could do it like this. I could do it this way. I could go, is it 255, right?
Yeah.
And if it's not 255, then that means the player's in the middle of a jump. So don't jump because you're already jumping, right? But to save a byte, you can save 1 byte by saying inc A because it's 255. It'll become 0.
Yeah.
And then because of that, if it's then not 0, right? It'll skip it. Yeah? You understand?
Okay.
Well, look, let's say here's your jump counter, right? And this jump counter is going to be 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, right?
Yeah.
Here. So if it's any of those numbers, it means that the player is in the middle of a jump, right?
Yes.
So this is our jump counter, yeah? It's going to reference here. That makes sense?
Yeah.
Sure?
I think so.
All right, so let me just recap a little bit, okay? So we have this thing here called the jump counter, yeah? Can you hear me?
Yep.
Yeah. Okay. So this is what this jump counter has 2 functions. One is the player in the middle of a jump or not, right?
Mm-hmm.
And the second function is whereabouts in the jump is the player,
Yeah.
right? So
Yeah.
so the possible values of jump counter are 255, which means not jumping, right?
Yeah.
And then we've got numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right?
Yeah.
And that's going to be our lookup to know how much to move the player the next time in the jump, right? So those are the possible values of the counter.
Okay.
And when the player's in the middle of a jump, we're going to be increasing that each time until we get to the end of the jump.
Mm-hmm.
See what I mean?
Yeah.
Now we'll come to that in a minute, but okay, so if we set the jump counter to 255, it means you're not jumping, right?
Yeah.
Now you'll see the reason why I chose 255 because here we'll say, okay, the player just pressed to jump, right?
Yeah. Yeah.
Let's say. So the first question we ask is the player already jumping?
Yeah.
So we need to know, so that question according to the code means, is jump counter 255, right?
Yeah. Yeah.
So what I do is I say increase A, because I know that by increasing A, if the jump counter is 255, it's going to hit 0.
Mm-hmm.
And that means that the player is not jumping.
Yeah.
Right? Okay. But if the player's in mid-jump, if the jump counter is, say, for example, 4, yeah,
Mm-hmm.
then it's going to go to 5, isn't it?
Yeah.
And 5 is not 0.
Yeah.
So therefore it means that the player's in the middle of a jump, and we shouldn't bother with with that, right? Okay.
Yeah.
But the reason this is handy is because if the player is in the jump, then the accumulator will be set to 0 because I just increased it from 255, right?
Yeah.
Which means I don't need to put X or A here because A is already 0 because it can't get to this point unless the player has already.
Right.
You see what I mean?
Yeah. Yeah.
Right? So set jump counter to 0 at that point. That makes sense? Yeah?
Yeah.
Good. Okay, so now somewhere else in the code, we would have something like the player is in the jump, right?
Mm-hmm.
And then, I mean, in this case, well, you might have something like no. Let's say this is no jump, right? Because it just means I'm already in the jump, so don't.
Yeah.
So just ignore that, right?
Yeah.
Okay, then somewhere else in the game loop, I'll just put a little line there. This is not the same thing, right? It's a separate part of the code.
Yeah.
You might have some code for like update jump, right? So we'll say, okay, let's go to the jump counter, right?
Yeah.
And we want to make sure that we are currently jumping, right?
Yeah.
So we will say, well, let's try this. Let's say, okay, so we go to this time. I don't want to increase it to 2 because I want to keep it at 0 if it's 0, right?
Well, yeah.
So compare 255. Are we jumping, right?
Yeah.
Something like that, right? And then we say JRZ not jumping. So therefore, we're not going to do anything. We're not going to move the player at all, right?
Yeah. Yeah.
So then what we do here, player is jumping, update Y coordinate, yeah? So what we want to do then is we're gonna read the jump table.
Yeah.
So we'll say now presumably this jump table, where is it, down here somewhere? This is only aligned to 16, not 256. So this is not necessarily going to be 0, 1, 2, 3, right?
Yeah.
It could be something like 20, 21, 22, 23.
Yeah.
But either way, should be okay to. I'll show you what we'll do. Right. So we're not. So the player is jumping. So update the Y coordinate. Right. So what we want to do is we will go load HL jump table. Right.
Yeah.
Then we will go load. Just a second. Well, let's put the high byte. This is how you do high byte of an address, right? Load H high jump table. That's give me the high byte of the jump table.
Okay.
And let me just think about this for a second. Yeah, okay. No, actually, no. Sorry, guys, I'm improvising here today. I hadn't made a plan, but hopefully it's all right. Okay, we'll go back. We'll put load HL jump table, right? And we've got the jump counter here to tell us where we are in the jump, right?
Yeah.
So what we'll do is we'll go add AL, right? So because A is the jump, where we are in the jump, and that means we're going to add it, and then we'll go load LA. HL now has address for the jump. For the jump operator, right? If you see what I mean.
Right.
Jump distance, yeah. Okay, I'll finish this off and then I'll explain to you what it does. So then what we do is we go load a ypos, add HL, load ypos a, and then we'll go to a jump counter a compare 11 JR. Yeah, just a minute. Jump done, and just bear with me just a minute. Sorry, right, we'll go. Okay.
Yeah.
So, I'll explain what we're doing here. Jump table here, and we are adding. So we're adding the jump counter where we are in the jump to our jump table address, and then putting that in L so that HL now has the address for the jump table, right?
Yep.
Okay. Now we've got here the Y position of the character, right?
Yep.
And I'm then adding whatever value is in HL to the Y position. So I'm updating it, right? So in this case, it's going to be -4. If it starts at 0, it's going to be -4. So it's going to subtract -4 from the Y position.
Yeah.
And then it's going to update the Y position, right?
Yeah.
And then that's done. So then, and now we need to increase the jump counter to the next one of the jump, in this case. So what we'll do is we'll load the jump counter and we will increase it, yeah?
Yeah.
What have I done there? Did I type something? It's a bit odd, isn't it? Yeah, we don't need that now. So, okay, so we'll increase the jump counter, right?
Yeah.
And then we'll compare the jump counter to 11, right? Because the total is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So
11.
basically,
okay,
are you at the end of the table? Yeah.
Yeah, I'm going to compare it to 12 then, right? My mistake.
Yeah.
Okay, so there are actually 12 entries there, and because from 0 to 11.
So what? It goes 1 to 12.
No, 0 to 11.
So you want the next one?
Yeah, because 0 to 11, that's 12 values, right?
Gotcha. Yeah. Yeah.
Okay, so what I'm asking it there is, have I gone over the threshold, right?
Yeah.
And then if I haven't, then just go to jump done here and update the jump counter to the next value, right?
Mm-hmm.
And then here, if I have gone over the threshold, then reset it back to 255, which means not jumping, right?
Yeah.
Now, in reality, that isn't the check I would actually do, right? Because what I would actually do is say, I've just completed the jump.
Yeah.
And now I'm on a platform, right? Or something.
Yeah.
So, I might put a different value in, maybe like 254 or something, right? I might check if I'm on a platform and then put 254, which just means I'm just falling now, right?
Right.
And then, like I've gone off the edge and I'll just be falling.
Mm.
So there might be a limit like that where, well, I mean, within AGD, what it does is it has something like this, and then I think it has like a few more values like that.
Yeah.
And so you just that last bit is just for like if you miss the edge and then you're just falling. And
Right.
there is there's a check for if you've fallen too far, right?
Yes.
So
Yeah.
if it hits if it goes beyond a certain point in the jump table,
Yeah.
then it means that you've fallen too far.
Okay.
So then what you might do is just keep the jump table at a certain number, like 16, and then he's just going to keep falling. And if
Yeah.
the jump table is 16, then you're checking for like, did it hit the floor or did it hit something, right?
Mm.
That's a whole different bit of code, but effectively,
Yeah.
yeah, you're basically just saying, oh yeah, did you hit something? And then if you did, then kill the player at that point, right?
Yes.
Or of course, you might also when you've done this bit of adding to the um, to the Y position, again, you might want
Yeah.
to check if they've fallen off the screen or anything
Yes.
like that, right?
Yeah.
Yeah, cool. So
Yeah.
yeah, I mean, I can't actually just quickly demo that because we haven't got the
No.
the code
Yeah.
Well, I suppose we might be able to within AGD or something,
I
but
mean, that's basically what I did in Next Basic.
yeah, but the
So,
thing is though,
so, I, so I
you can actually
yeah,
understand all that now, right? It's not
yeah,
you're
yeah,
starting to see assembly as something that's
yeah,
not nearly as scary as you thought it was, right? I
yeah.
mean, I think the only new command there that I've shown is that one, add HL, right? Which is quite a
Mm,
handy one. HL is pretty flexible compared to the
right.
other register pairs. You can't do add DE and you can't do add BC.
Yeah.
So yeah, excuse me. Um, so getting back to this code, let's take another look at it and see where we get to. If you're up for that, I guess it's only 3:40 my time. I've got a bit of time.
Yeah.
Don't want to go too late, but anyway, that's a
No,
that's a
no.
basic concept of the lookup table and how it works. You guys in the chat, I hope that all makes sense. There's only, I think, Mitsuyama and Tails are there anyway, but there are
Yeah.
people who watch it later on as well. So, hello, future people. This is past me. Yeah. So I don't remember what this does. It might.
That looks very different to the one I've got. Must admit.
Well, let's just run it and see what it does because I don't even remember what it does. It's an important lesson here, though, guys, which is always annotate your code well so that when you come back a month later, you've got at least an idea of what it does.
I've got one that's XY plot, and I've got like basically two functions going in there, which I think was me trying to get it working together. So probably not the best start.
Right, let me see if I've got the code here. All right, there you go. So it was basically plotting along the y-axis all the way down. Yeah, that's
No plot Y.
So let's take a look.
That's not the one I have. Hold on. Yeah, I wonder whether you worked on this with.
No, I didn't.
No.
No. To be fair, I mean, Dom is he's a few steps back before you, so I wouldn't do that. Instead, I just took it as a chance to do a bit of revision with everybody.
Right. I don't know. I don't have anything that has draw Y. Hold on. Let me that pixel plot. What pixel plot Y? .asm. Let's have a look.
What I can see from here is that this part of the code is not currently.
Right, pixel plot Y. Let's load that up. 40152. Okay. Yes. 2. Right. So I'm putting the pattern there, and at 60. Okay. So if I do that at 0. Right. Okay. So I've got plot Y working. I think mine might be slightly different to yours.
Yeah, I mean, I'm trying to figure out what all of this is here. Well, I tell you what, I have an idea. I don't know if I've got the code here to do it. I might have, though.
Yeah.
No, that's no good. Just a minute. What I'll do is I'll show you how we can use lookup tables to do it, because okay. Yeah, so this will be an easy way.
Right.
What's that?
Okay. Just looking at the amount of data that you're selecting.
Yeah, well, this is the fastest way that you can do plotting, right? I'll show you now. Okay, so we may have to just forget about all this that we. Let me make a new. I'll make a new one. Okay. I'll call it table plot. Tableplotter.asm. Okay. This actually won't take that long to do, because if you want to do like a particle engine, for example, right, and you want to plot pixels really quickly, then you really don't want to be doing screen calculations, right?
Okay.
So instead, what you do is you use lookup tables to give you all of the appropriate addresses that you can look up, right, using X and Y.
Okay.
And the way that works simply is that if you imagine that you've got the y-axis, so you've got lines, right? And then you want to know how far across on that line. See what I mean?
Yeah.
To find, go find your line and then go across and then plot it at that point.
Yeah.
Okay, so just bear with me then. I'm going to put all this data in here. And then I'm just going to do that. Okay. So what I've got here is I've got 3 different lookup tables, right?
Yeah.
We probably need 4 lookup tables because we need a pixel plot lookup table as well. But now, if you imagine, right, so you've got 32 bytes across on the screen.
Yeah.
So the first 8 pixels are at byte 0, right? The first 8.
Yeah.
And then the second set of 8 are at byte number 1.
Yeah.
Right? So that's why you see the lookup table for X is like 8 zeros and then 8 ones and then 2 and 3, right?
Yeah.
And it goes all the way across to 1F over here.
Yeah.
Which obviously is 31, right?
Mm-hmm.
So that's the value that we're going to add. So we're going to find the point on the left-hand side.
Yeah.
And then we're gonna add this value according to our X. You see what I mean?
Yeah.
Okay, and to find the value on the left-hand side, you need to know the low byte and the high byte. Yeah?
Mm-hmm.
So essentially, what all these numbers do is they allow you see here how it goes.
Yeah, you're going through
40
between
to
the 3
47,
different
right?
sections of.
Yeah, this is the first segment, and in each segment, what it's done is it's reordered. What you're doing is you're reordering the screen memory in a way to a logical, linear way, right? So that's your first segment there, right?
Yeah.
And then you see there it goes to 48, and then you see that's probably, to be honest, it would be, I think it would be clearer.
What's the bit above?
Well, I'll come to that in a minute. It would be clearer if it was like that, right? Because you can see that this is the segment each time.
Right.
Right?
Yeah.
And that's so what happens is you repeat that however many times. I guess it's 8 times. Like this.
Yeah.
Now, obviously, what you're doing here is you're repeating yourself a lot, yeah.
Yeah.
But the reason that you're doing that is because of the speed that you want. You just because you want instant. You want it like instantly. No adding, nothing. Just give me it instant. Right?
It's just raw. This is where it is.
Yeah, just literally exactly tell me the address. This is what I used in Asteroids RX, and I use it in most of my arcade games because you just want that instant lookup. You're just saving yourself the time because every second count, every nanosecond counts.
Yeah.
So yeah, look, I won't go through and change all of these because it'll be a bit of a.
Yeah.
Well, although actually, I suppose it's fairly. It wouldn't be that difficult to say. Well, look, you've got like 1, 2, 3, 4, 5, 6, 7, 8, and then another set and another set. Right now, in this case, I've actually got a lookup table that when it gets to the fourth quadrant, the fourth sector, there isn't one, right? So what I did with Asteroids is it goes back to the first one again. So if you plot y as above 192, then it'll actually plot it as though it's looped over.
Okay.
You see what I mean?
Yeah.
Back to the first segment again.
Yeah.
So yeah, basically this is the high byte of the y table, right?
Yeah.
But obviously, as you know, that's only going to cover the sort of well, when you add the high byte there, you're covering one square, the top square, right? The top square of each segment. You see what I mean?
Yes.
So just to be clear, the X lookup, that's getting us from 0 to 31, right?
Yeah.
And then the high byte here is going to cover the top square of each segment, right? But the low byte is going to cover the other squares. I should say that the high byte controls the position within the square, so it's kind of fiddly the way that the spectrum memory works. But suffice to say that if I put my let me put it this way, right? If you give me a y coordinate
I know.
from 0 to 100 and what?
100. 100.
100, right? Okay. So if I, well, yeah, okay, well, if I basically look up the 100th number in this table, right?
Yeah.
So, well, let's say, so that's 8, right? So, so that would be 80. That would be 88. That would be 96. So it's probably going to be like this number here, right? Maybe.
All right.
In fact, look, I tell you what, we can make this a lot easier by, I think we can actually do that, right? So you can see where everything is. Okay, so I've had an error there. Just a minute. Where's my... it's because I typed that in. Typed your number. Think of the number you were first. Right. What's the number you first thought of? Okay, so let's say 100, right? 100 in hex is 64, right? 64. Yeah. So if I go to the Y lookup table here, and I go to C164, yeah? So this is Y lookup low, right? So C164 is like an index, yeah? I can see that C164 is 80, right?
Yeah.
Okay, and now I'm going to go down here and look in C264, which is the high byte table. C264 is 4C, right?
Yeah.
This is 65, 66, 67, right? So this is
Yeah.
4C. So what that tells me is 4C80, right?
Yeah.
So 4C80 in decimal is going to be 19584, right?
Okay.
Okay, now I'm going to go to the spectrum and I'm going to just poke it, right? 19584, and I'll poke it with 128 because that's going to be like the 1 pixel, right? Okay, and there it is, right there. You'll see. You wait for it in a second. It'll come up.
Yeah.
Right, and that's y coordinate 100. You see.
Okay.
So, in other words, this is an index. These are all indices, yeah, basically, to give us any address on screen, whatever we want. So, and the other thing I would do is let's say I wanted it at 100 by 100, right?
Yeah.
Then, well, what I would do is I know that the address we already got, that address was 19584, right?
Yeah.
But if I then go to the x value here, this is the x lookup, right? And I also look at where 100 is, 64, it's OC, right?
Right.
Which is, what's that, 13? C is 13, right? 10, 11, no, 12, sorry. 12, yeah? So what I would do is I'm just going to add 12 to this value because it's going to go across the screen. 19596, right? So if I poke 19596, now obviously there's the pixel pattern to consider as well, right? Which you haven't considered. But if we
This stream is paused. It's not.
No, that's weird. Okay, well, there you can see, and that's if you wait for the stream to catch up, right?
Yeah.
You'll see that's roughly at 100 by 100 now. See?
Yeah.
So you can see from that how much easier it is to plot, because all the calculations that we did in that simple demo, they've all been done already, and we've stored them in these tables, right? Now, obviously, it's taken up quite a lot more memory, but it's massively, massively faster. Yeah?
Yeah.
So let me show you then how we can use these lookup tables to plot something quickly and easily. So we do need one more lookup table, right? Which is our pixel pattern. 0, 1, 0,
Yes.
what is it? 128, 64, 32, 16, 8, 4, 2, 1. Okay, 8 different values. So for those of you guys that are slightly confused by this, we did another video on this. If you go back to previous videos, you can see how this works. But essentially, these values are, so within a byte, you've got 8 pixels, like that, right? And what we're doing is, this is the pattern here. This is 128, there's 64, sorry, that's 64, that's 32, that's 16, that's 8, that's 4, 2, and 1, right? So that allows us to plot a pixel within a byte line like that, right? And within on the spectrum's screen, you've got 32 bytes across, right? So when we're plotting on the x-axis, there are two things we need to know. One is which byte do we need to poke to, And then secondly, which pattern do we need to poke to plot in exactly the right position? So the lookup table, the X lookup table that we're looking at there, will focus in on a particular byte like this, 0, 1, 2, 3, 4, right? And that's why. So when you look at the X lookup table, you'll see it says 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2, right? And that means that if X is anywhere between 0 and 7, right? 0, 1, 2, 3, 4, 5, 6, 7. So if X is anywhere between 0 and 7, it's going to be, let me move this up, right? So that we can see the two things together. So if you imagine that this is the screen with these bytes going across, right? Like this.
Yeah.
Yeah, and each one of those is a character square. And that'll be 8 along, right? So when I'm doing a lookup, I'll move that out of the way just up here so that we can, yeah, that'll be easier to follow, I think. So if you say, let's say for example, X is, I don't know, 17, right?
Yeah.
So this lookup table, I'll go, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right? So that number there, 2, that tells me that we're going to be using this, the second byte along, right?
Right.
There. And then, do you remember how we use this pixel pattern? It's pretty straightforward. But if you look at, let's say we wanted the number 17, right?
Yeah.
So we want to know which of these patterns to reproduce.
Yeah.
And effectively, it's actually fairly straightforward because it's going to be, all we need to do is just look at the three numbers here, right? Which will give us a number from 0 to 7. So 17 is an odd number, right? And it's going to be, this is going to be 17, that's 17, right?
Yeah.
I think that's 17, isn't it? Yeah.
Yeah.
So all I'm going to need to do is mask off this part here because we only need the last three numbers to tell us the pixel pattern, right? Because it's going to be a number between 0 and 7, right? Because there's 8 different pixels that we can light up. Yeah, see what I mean? You sure? Because I've been through this before, but you remember it, right? And then we use that. We use that number, and we use that to look it up to get a value, and it'll either be 1, 2, 4, 8, like that, right? So if this value here is 1, yeah, then effectively that means we're going to use. I think, have I done that the wrong way around? I'm not sure. Let me go back a second. Sorry about this. No, it's fine because that, yeah, if the value is 1, then it would be that one, right? So anyway, we'll figure it out. Okay, Mitsuyama, yeah, no problem. Catch, it's just me and you, Andy, actually left, I think.
Yeah, it is.
Anyway, all right, so let's run through that. This is the quickest way that you can plot, really. Okay. So we put that. Let's say we put our pix pattern there. Okay. And then you can just, you can play about with this and see where you go. But I'll put the pix pattern down here at the bottom, right? Now, because that's 256 numbers, I actually know that that's aligned, right? Because each of those is 256 anyway. You see, that one doesn't have a line 256 because this is 256 numbers. So it didn't.
Yeah.
Well, I need to put it. I need to put it there. Right? Okay, so let's put X in here, right? We'll call it X position. And we'll just choose some random numbers, right? And Y position. Plot a pixel quickly, right? Okay, so what we do then, it's a fairly straightforward thing, is we'll start with, let's say we start with our X, right? So we'll load H, high, X pos, right?
Okay.
So that's putting our high byte into this table. But we haven't said which one of these 256 numbers we want, right? We're just pointing it at that, right?
Yeah.
So load 8 high X pos like this, right? Then we go load A, comma, X position, right? And then we go load LA. Put the X value into our table, right? Then we will store it for later, right?
Okay.
So that's giving us the value of our X lookup there. Okay, now we now go to the Y lookup table, but because we've got this aligned, all we need to do to go to the next table is increase H, right?
Sorry, I don't get why. Because the table what? Why are you not using the table number? The table name. Right, you put an XPOS.
Yeah, I beg your pardon. That's my mistake.
Okay.
Good point. X lookup.
Yeah. Okay.
It's 4:11 a.m.
At least I understood that.
Yeah. It's great. It's fantastic. Good job. Yeah, absolutely right. Good job. Okay, so so that's the lookup table needs a high byte and a low byte, right? The high byte tells you which lookup table you're using because they're all 256 bytes, right?
Yeah.
And the low byte tells you the index within it, right? So it's pretty easy to understand, right? So we set the table up, and then we get get our X position, and we set it to the index, and then we read it.
Yeah.
In this case, I'm storing it in C, right?
C, yeah.
Just because I'll need it for later.
Okay.
Okay, now if I go increase H, then that's going to step up by 256 bytes. It's literally going to go from the X lookup table to the Y lookup low byte table.
Okay.
Right?
Yeah.
So all I do, so then you see, easy, very, very easy. All I need to do, in fact, is that low byte now. I actually just need to add the X value to it, right? That makes sense? Yes?
No.
So when you've got, imagine what I've got is an address. The Y lookup table is going to give me an address of the left-hand side of the screen, like all the pixels down the left-hand side.
Yeah.
So to get the screen memory address for the X value, I have to add my X value to the low byte of that number on the left-hand side, because otherwise all the pixels, right? See what I mean?
Yeah.
So when I'm looking up the next thing in the table, it's telling me the low byte of the left-hand side of the screen. down. And then all I'm going to do is add X to that to get the actual byte that I need. See what I mean?
Okay. Yeah. Yeah. Yeah.
Okay. So I go to the Y table, right?
Yeah.
And then I can load A, get the low byte, right? Right?
Right.
Something like this.
Yep.
Yeah?
Yeah.
Okay. Because L doesn't need to change because it's going to be the same each time, right? Now, but what you might notice actually is that what I could do here is instead of storing it in C, I could store it in A, right?
Yeah.
And then I could use add HL, right?
Okay. Yeah.
You understand why that works? Yeah.
Yeah. Yeah.
So we've got the value for the X offset. It's an offset, right?
Yeah.
And then we go to the next table and we
Yeah.
add that offset to the new lookup table, the low byte, right?
Yeah.
And now we can store that for later because that's our low byte. That's our actual byte that we're going to need, right?
Yeah.
So we'll store it as a low byte in E.
Okay.
Right? We'll just store it there for now so that it's done. Okay, and then we go to the high byte, next table down again, right?
Okay.
Got it?
Yeah.
So next table down again, and now we just need our low byte, right? And we don't need the lookup table anymore. Well, okay, so what we'll do is we'll go load DHL, right?
So what's the next? We've gone to the Y table. What's the next table?
Next table down is the high byte, you know, the segment or whatever, the high byte
Right.
here, right? And this doesn't need to change. See what I mean?
Why?
Well, I mean, what I mean is like, you know, when we look up the low byte, we have to add the X value to it, but we don't need to do that with the high byte. See what I mean?
Yeah. Okay.
Right? So that one doesn't change.
Yeah.
Whereas this low byte, it changes depending on where your X value is. See?
The X value is yeah.
So
See that?
right? So it's because essentially you've got 256 bytes squares, right? Or 256 squares, whatever, right? And then you've got a line within each square. That's the high byte, and so that's going to be the thing that anyway.
Okay.
That's done. That's all done for you automatically, right? So if you look at the code now, so we've got the lookup table, we've got the A, right there, and now we're pretty close. We're actually pretty close to having the correct address already in DE. Yeah.
Right.
In fact, we've got the correct address. What we actually need now is the pattern, right?
Yeah.
And that actually comes from the X position up here.
Yeah.
So what I'm going to do is because we're not using register C, right? So we'll store the X position in here as well, so we can bring it back and use it for the lookup table. Because if we now increase H one more time, yeah, we'll be going into our pixel pattern, which is here, right? Now, obviously, L is not correct now, right? Because what we actually want is a value from 0 to 7, right?
Yeah.
But that should be pretty easy to do, because all we need to do is load C into the accumulator, right?
Mm.
Then mask it off. So we only get the first, I think, am I doing this right? Let me just double check, because, I'm just working off. Yeah, here, you see? Similar thing here, right? You just and it there.
Yeah.
Like we did before. So we and that off like that. Yeah. And that gives us from 0 to 7, right?
Yeah.
So and because where we've stored the pixel pattern, we know that actually starts from 0 because it's aligned, isn't it? Remember?
Yeah.
So we know that's actually our value that we need. So we can just go load L C, right? And then load A HL, right? That's the pattern.
Yeah.
That makes sense?
Yeah.
Sorry, this should be load LA, right?
Yeah, put C into A, yeah.
Yeah, because we've done that calculation. So that is the byte value to poke, right?
Yeah.
So to poke it, all we actually need to do is poke. I'm typing poke. What am I doing? Load DE, comma A, right? Because we calculated the address there. See?
Yeah.
But now, bear in mind though, we might have something on the screen already, so you might want to plot more than one pixel in one byte. Yeah?
Yeah.
So what I would do in this situation is I would do this. I would do XDEHL, right?
Okay.
It's a very quick register swap. And I put it in HL because HL is more flexible than DE, right? And we've got our result now. We don't need our lookup table anymore. So then all we need to do is we've got our byte value here, right? So we OR it with the value that's already on the screen in the screen memory, right?
Right.
And then we put it back on the screen. It's all a bit silent.
Well, I was listening. I heard a noise and I wondered where the cat was, but I see. Yeah.
Right. You see what I'm doing there? So I've got,
think so, yeah.
This is my pixel value, right?
Yeah.
That I want to poke into the screen.
Yeah.
But instead of poking it straight to the screen,
yeah,
I'm gonna OR it with whatever's already on the screen.
Yeah. Yeah. So if it's there, it stays there. If it's not,
so that if there's another pixel in the same square,
yeah,
it'll draw it and it'll mix the two together, right?
Yeah.
And then put onto screen, right?
Yeah.
Okay. So if we run, let's hope that we got it right. But okay, and we'll do one more thing after this as well, just for a bit of fun. That should plot.
You got 2 errors.
Ah, okay, 2 errors. What are they? Oh, unrecognized instruction. Yeah, because I haven't put def b in my lookup tables here. It's always schoolboy errors. There we go. Def b. All right, that should get rid of them. There's 2 errors, but still, yeah, recorded it twice. So in theory, at least, then that should simple demo be. Oh, take. What have I output? Simple. I've output it as simple demo, haven't I? So So randomize. What's a 49152? Right, and there's a pixel right there, right? Did you see it? It should appear on the screen.
I'm on the waiting on the stream.
Yeah, no problem.
Yeah.
So yeah, that should be whatever 32 by 81. Does it look about right? 32 by 81. I guess it looks about right. I'm not sure. 81 looks doesn't look quite right.
81. It looks like it's 31 by 31 or something, or 32 by 32. Right?
Yeah, maybe we've done something wrong somewhere along the line. Let's see. Load A. Load A. Yeah, I can't see anything wrong there. Weird. Okay, well let's try something then. Let's go like this. So we'll go load A. Now let's say load B, comma 192. Load A. Call plot pixel. Load A. 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 PJZ. Test. Vertical. And direct. Right. We'll just put a couple of halts in here, right? Just to slow it all down. You see what I'm doing there?
Yeah.
I'm just doing a straight down line.
Yeah.
Right?
Yeah.
See what's going on. Maybe there's something wrong with the lookup table there. I don't know. I don't remember what lookup table I was using with
Right.
Donkey Kong, but I'm pretty sure it's right. It's almost certainly a mistake that I've made somewhere along the line. So no, that's just got stuck, hasn't it? That's weird. Not using register B there. Okay. Oh, look, I haven't looked up the Y position. Oh, that's a bit of a silly thing, wasn't it? Because L, of course, I've done everything on the X position.
Yeah.
Right. That's why it's 31 by 31. Because of course I've got to change.
Yeah.
Yeah. Of course. Yeah. So then we do need to store. Right. Okay. So what we actually need to do is let me think about this for a second. Yeah. Okay. So we'll store in E temporarily, right? The X value.
Yeah.
And then we'll go to the Y table. Yeah. Then we need to go load a Y position, of course. That's such a silly error. And then load LA. So that keeps us in L. The Y. So we're looking up the Y. We were actually looking up X, comma X.
Yeah.
Right, which makes sense as to why you know. Right. Okay. So load LA. and then load a H. Well, actually, we can go a number of different ways with this one, actually, but we could say load a HL and a E. Yeah?
Yeah.
So add the X value here. And then we don't need E anymore, so we'll just put the result into E there, right?
Yeah.
Yeah, stupidly hadn't used the Y position at all. Now, I'm going to take out these halts as well. I think that's what's causing that crash. Okay, so yeah, pretty easy. I'm surprised you didn't spot that deliberate mistake I made there, Andy. Just trying to right. Okay, let's go reset. I'll go 48K basic and that demo in 49152.
Would this work on a 1 to 8?
There you go. You see how quick that was as well. A second. Look how quick it is.
Yeah.
Bang. Instantaneous almost, right?
Yeah.
Well, it works in 48K mode. Yeah, it would work. 1 to 8K is pretty much the same, almost identical. It's just that It's just that the top 16K of memory is you can swap it out and point it to different places, but otherwise it's more or less the same, right? Okay, so now we've done that, let's have a little bit of fun. And okay, so what I'm going to do is I'm going to show you how a quick way of doing a random number, right?
Yeah.
It's quick and dirty, but it works in most examples, right? So I've got a random seed here, def b0, right? Okay, and then what I'll do is I will let's say, right, so we'll load A with a random seed, right?
Yeah.
And I think, can we do add AR? I'm going to have to check that. I'm not sure. R is like the refresh. It's a fairly random thing. It's out of time.
Okay.
I can't remember if I can do add AR. So I know I can do. I know. Well, I can do load AR, but I don't know if I can do add AR.
Right.
I suspect not actually, because it doesn't ring a bell. No, I can't.
Oh.
Yeah, special instruction. All right. So what we'll do is we'll go load AR. Okay, and we'll go load HL rand seed, right, like that, and then we'll add HL, right? So we're combining the seed with the refresh, right?
Yeah.
To give us like a pseudo random number, yeah.
Yeah.
And then we'll go. Let's just see what we'll do. Let me think about this for a second. Yeah, this isn't ideal, but we'll do it anyway. What I need to do is let me think about this for a minute. So what I'm going to do is use the ROM, you know. To just look up a random number. But what I want, ideally though, what I want to do is, I don't want to just use the first 256 bytes in the ROM, you know?
Right.
Because there's a limited amount of numbers in there, you know, they won't all be in there, so. Yeah, let me think about this for a second. Okay, load. Okay, what we'll do is I'll get the random seed, right?
Yep.
And then I will and 15. No. I want to read the ROM, the bottom half of the ROM, right? So that goes up to about 63, I think, isn't it? Yeah. And then we'll go. Let me think. So I'm making this more complicated than it needs to be, but anyway. Uh-huh. Okay, I'll explain this to you, right? Just give me a second.
Yeah.
So you understand that the Spectrum memory has a ROM, right?
Yep. Yep.
And it goes from 0 to 40 roughly, right? Or
Yep.
3FFF actually, right? Like that. Yeah. So if I want to get a random number, one of the things I could do is get a fairly random address, generate a fairly random address within the ROM, right?
Mm-hmm.
And then use that and read whatever value is in there, and it'll be fairly random. See what I mean?
Okay.
So, so I want it from 0 to 3F. So what I'll do is 40 is 63, by the way, right? So 64. So anything up to 63. So what I'm doing is, okay, I'll start with a random seed, right? Which is going to change every time I do a random number. That random seed is going to change.
Right.
So and then I'm going to store it in C just so that I can use it later. Then I'm going to AND 63, so it's only from the ROM, right? And that's going to give me H. H value is somewhere between 0, 0 and 3F. See what I mean?
Yeah.
You sure?
Well, to a degree, I guess. What? Maybe not the round seed, to be honest. I don't.
Okay, so what I'm doing, I'm using the random seed to each time that you do the random number, it's going to go to a different. It's going to go to a different. It's going to go to a different place in the ROM in terms of the high byte, right, from 0 to 63, so that it's always jumping around the ROM a lot instead of reading it only from the first.
Like, but how is it getting round? How is round seed that? Is that what that is?
Well, look, it's the random seed starts out at 0, right?
Yeah.
But if you look here, at the end, I actually update the random seed to be the random number that I've just generated, if you see what I mean. Right? So I'm generating a random number, and then I'm feeding that random number back into the random generator, so that the next time it'll look in a different part of the ROM.
I'm just not seeing where the random number comes from.
Well, the random number comes from the next part here, right? Because what I'm doing is I'm getting a number from 0 to 63, right, which is my high byte, yeah?
Oh. Well, I didn't know. I didn't. Yeah, I had no
See,
idea
there,
that's how that worked.
That's my high byte there. I'm loading an address in the ROM.
I didn't know and 63 gives you a random number.
No, it doesn't.
Oh.
You see, look, what that does is it gives me it cuts off any number above 63.
Right.
Because the ROM address is from 0, the high byte is from 0 to 63, right? In 63 is 3F. Okay.
Yeah.
All right. Yeah. All right. Don't worry. Look, it's a little tricky. I'll explain it. Okay. So you understand, right, that the ROM address is the ROM for the Spectrum goes from that address to that address. That's clear. Yeah. You know that, right?
Yeah.
Okay. So you know in there's like loads of code.
Yeah.
But it could also just be a load of random numbers, right? Remember when we loaded numbers into the code, into the thing? It just looks like random garbage, right?
Yeah.
So if I can dip into the ROM at a sort of pseudo-random point and read a value, it's going to give me a fairly random number.
Yes, but that's the bit I'm
okay. So what we need to do is figure out how do we get the actual address randomly, right?
Yes. Yeah.
Okay. So what I'm doing here to get that address, yeah, I start with my random seed, yeah,
right, which is 0,
which is 0 now on this round, only on this round, right? But that doesn't matter because the result's not going to be 0. But anyway, and so, and then I'm going to AND 63 because look, this random seed is not always going to be 0. So what I need to make sure is that it's always less than 63 because 63 is 3F here, right? So I don't want to go above that number.
Okay.
3F. You see what I mean?
Yeah.
Okay. And then that means that in H, I've got my value from 0 to 3F. Yeah. The first time it does it, the value is going to be 0, right?
Yeah.
But the next, because I don't want just one random number, I want lots of them. So the next time, I'm going to update the random seed so that it's not 0 anymore.
Okay.
Right?
Yeah.
Okay. So.
Yeah.
Missed out something there, right? So then what I do is I get the refresh, which is fairly random. Yeah.
And what is the refresh?
It's a refresh register. It's to do with like the scan lines and stuff. It's a pseudo random number, right?
All right.
If you the refresh right. So basically it's to do with the timing of the PC, right? So when that runs, yeah, it's fairly like at what point that is going to run during our code is going to give us a fairly random number, right?
Okay.
Because we don't know. It's literally like an unknown number, right? Which is fine because then
between
we can use it.
Though?
Well, between 0 and 255.
Okay.
Yeah. And what I'm going to do to make it a little bit more random, then I'm going to mix in the original random seed as well.
Okay.
Right, and I'm going to put that as my low byte.
Yeah.
Yeah, so that's going to give me an address somewhere between
Okay.
0 and 3FFF, right?
Right.
Then I'm going to load what that value is. That's going to be a random number from the
Yeah.
ROM, right?
Okay.
That gives me my random number that I want.
Okay.
But then what I'm going to do, that random number then becomes the seed, so that next time it'll be in a
Mhm.
totally different place. You see what I mean?
Yeah, I do, I guess. But if you're saying that R will give you a random number between 0 and 255,
Yeah, but it's not sufficiently random enough to
isn't it?
no.
Okay.
It's a fairly rough random. I mean, to be honest, I'm not even sure. Um, it's just the way that I've seen different code. I mean, there are different ways of doing this, but I understand what you mean. Why don't we just take the R register
Yeah,
and use that as a random? Well,
exactly.
because it won't be random because it's like it's in a cycle. It's going like perhaps it'll be like 0, and then
Right.
the next time it'll be 23, and the next time it'll be 45, and the next time it'll always keep going up. It's like so we're just trying to mash it up a little bit, really. It's like
Okay.
it's like imagine you've got a clock, right? A
Yeah.
stopwatch, and it's going
Yeah.
round, right, every
Mhm.
60 seconds, yeah? So, and
Yeah.
then I say to you, how many seconds, like, and you go, oh, it's
Mhm.
31, right?
Okay.
And I have no idea. So that gives me a number. But if I ask you again after like another second, it'll be
Yeah.
like, oh, now it's 34,
Okay. All right. I get you.
right?
Yeah.
So it's not enough.
So
But
right.
but
So
by putting it into the ROM, an
yeah.
address, and we know that each time it does it, it's got a different low high byte as well. Then
Sure.
it
Yeah.
makes it a lot more random, right?
Okay. All right.
Otherwise, you're going to get random numbers, which is going to be like 0, 3, 7, 12,
Yeah.
or something like that,
Yeah.
maybe, right? I mean, I'm not an expert here, but anyway, that's
So it's a random incremental number until
well,
it wraps back around.
yeah, it would be, yeah, it'd be fairly random, but not properly random. Whereas if I
Yeah.
put it if I point it at the ROM and get a number, it's going to be a lot more random, like,
Yeah. Okay.
because what,
That makes sense.
right, okay. So what we'll do then is we'll go to we'll keep it arrow, and then we'll go call get random, right? And then we'll load xpos a, yeah, and then we'll
Yeah.
call get random again,
Yeah.
and then we'll load xpos ypos
Yeah.
a, right? Now that's not going to fill the screen, but it's going to do like a load of random numbers, isn't it? So let's say we load b with 100, right?
Mhm.
And then we go like that, right? So that should give us like 100 random pixels. See? Theoretically, anyway. I mean,
Yeah.
to be honest, I don't. Most of the time I'll be honest, most of the time when I use a random number generator, I just copy and paste it from somewhere else, and not worry about
Right.
it. Don't even think that
Yeah.
much about it. Um, there's loads of examples that you can find because coders love. Right, well there you go. Look, it's just continually looping. It's not stopping at 100. But
Okay.
anyway.
Oh yeah. And they're more clustered to the lower numbers than the higher numbers, aren't they?
Yeah, yeah, a little bit. See, 'cause it's not proper random, you see.
Right. Yeah. You can see squares of yeah. Yeah.
Interesting though, isn't it? But yeah, I mean there are different ways that you can do.
I'm surprised it's not actually a function to get a random
Oh
number.
no, there is. Yeah, there is. But
Oh,
I mean, like most of the time, right? The thing is, most of the time when you generate random numbers,
yeah.
Usually you don't even want 255. Usually you only want like 16 or something. So,
right.
you know,
Okay.
like for example here, if I do that, yeah, and 31,
Yeah.
then it's going to give me like only numbers between 0 and 31.
Yeah.
I mean, I can show you. We can copy and paste something in if you want to do like a random code. There's loads of examples of random number generators because
Okay.
some coders are really like, no, that's not like they look at what I've just done and they say that's not random. Look, you can see it's not proper random. But
Yeah.
in a game, it really doesn't matter that much, you know.
Mm.
So it doesn't happen that often.
Yeah.
So, you know. There you see. I mean, that's just plotting into that square, and you can see that you know
Mm.
there are certain numbers that aren't going to come up. Look,
Yeah.
and the reason you'll get that it'll look like lines because it's those numbers that are not coming up for both x and y.
Yeah.
You know,
Yeah.
but it's kind of
Mm.
fairly good, right?
Yeah.
But if you go online, you can easily find examples
Okay.
of other ways of doing it, right? So
Yeah.
like I'm just seeing here, someone's done a pretty simple random number generator here. You'll find loads of these.
Yeah.
I'll pick one out just a minute. People are always coming up with new ways of doing it. So I'll copy and paste and we can try it out, right? So I'll take this out and I'll take that out so we get, right? And then we'll basically, you can just experiment with different randomness and see what you get and if it's enough, because it only needs to be good enough, for the game.
Yeah.
It
Yeah.
doesn't need to be like mathematically perfect. You might have some
Yeah.
kind of coding competition where people are trying to do the best, really truly random.
Right.
And that's why you call it pseudo random, It's not really, really random. And here we've got random seed, so it needs to be, it says 2-byte seed located in RAM. So def, def B, yeah?
Yeah.
Well, this you can also do def W, and that means a 16-bit number, def word.
Okay.
So we would say rand data, def word, I don't know, 24, whatever. Yeah, I'm presuming that's gonna. Well, let's put def word as 2, 1, 2, 3, 4. Yeah, fine, right, okay. We'll see if that makes any difference to being a bit more random. Generally, none of these are perfect. They are pseudo, but most of the time they're more than sufficient to.
Got 3 warnings.
Oh,
3
sorry.
errors. 1 warning.
It's good that you told me. What was it? What is the warning? Reading memory at low address 0.
And data is wrong, it says. Oh, because you're a space out at the start of the line.
Yeah, okay. Good spot. Like I said, I do all these things on purpose. Right. Okay, reset.
The thing is, I hate that about about coding and scripting, it should be more.
Well, it stops you from making mistakes. It does stop you from. It's a lot harder, right, to try and find errors. You know what I mean? If they come up straight away, then you find them and you fix them. But if you do it and it's like it's doing something intuitively, it thinks it's got it right, then it can be really hard to find it. You know?
Yeah.
To be honest, you get used to it easy enough. We'll try this one anyway and see.
But like in the syntax, that should warn you that there's a space.
Oh, that's a lot more random, isn't it? Look at that. But there's a little island in the middle.
Oh, I'm behind.
Yeah. Hold on. It's very interesting.
Oh yeah. Oh, it's the top half of the top third of the screen is a little bit more heavy, isn't it?
Yeah. It's getting there though, isn't it? Look.
Yeah.
Look at that. There's this little island there where no numbers, where the random numbers don't occur.
It's weird, isn't it?
Yeah. It might be kind of fun to try different routines and see the different effects, you know.
Yeah.
I've got one more routine here that someone's done. There's a few actually.
I'm going to need to make a move in a bit.
Yeah, fair enough. But look at that. There's definitely like just a little bit there.
Yeah, there is, isn't there?
That the random number doesn't like. It's just yeah. Interesting. It plots it pretty quick though, doesn't it?
Where's my cat gone? Where's she gone?
Right, get random 2. Do that.
Hey.
Ah, yeah, look, you see, it's on an infinite loop. I didn't even need to load B 100 because I've actually got it jumping back to the start. So it's just doing loop after loop anyway. So I just go like that.
Yeah.
Anyway, I'm just going to put in get random 2. Are you coming out now, Kiss? Kitty cat? You coming out? Okay. Yep, she's coming out as well. Here she is. Hello. Hello. Hey. Say hello to the world. How you doing? How you doing, little one? Look, she's so affectionate.
Oh. I don't know where mine's gone.
Oh, you're so happy, aren't you? Hmm? Oh, yes. Say hello to the boys and girls. Hello. Hello. Yeah, camera's there. There you go. Good girl. Right, then. You go down there for a second. We're just going to do one more random number thing, and then we're going to call it a night.
Bubble, where are you?
Wow. Mm-hmm.
Bubble.
Yeah, wants to play because I've got the cable.
Sorry, mate. I'm just trying to find her. I don't know if she's gone.
All right. Well, listen. How about we wrap this up, and then you can
Yeah.
I'm sure she won't go anywhere in the next couple of minutes. Oh, that's not a very random number generator, is it? Not at all. Something missing with that one.
She's in the cat bed that they never ever use.
Ah, well, they always keep you on your toes, don't they?
Oh, nicely balanced.
Yeah, she's very good at that. Yeah.
Oh, that was very different, isn't it?
It is, yeah. Go on. If you're going down, go down. Okay. Well, yeah, that's not random at all, really. I think
No.
I might have missed something out there. I think I might, perhaps just to be sure, might be that, I suppose. We'll see. Could be that. Could be I just made that mistake.
Hmm.
Anyway, can't be bothered to look into that right now.
No worries. 'Tis late.
Yeah, that's just doing that. I don't know why. Not to worry. The other one's good though. The other one's pretty good. I like that other one.
Yeah.
Apart from that little tiny island in the middle.
Yeah, that was odd, wasn't it?
But yeah, anyway, that's how you plot pixels using lookup tables. It's a lot quicker.
Yes. Yeah.
There you go. That one's good. That's good enough random distribution, really. We're not getting that same island either now. Look, it's high. It's a different
No,
pattern. Look,
the top half of the screen.
more at the top. Yeah,
Yeah.
it's not that much in it though, is there?
No. No. Well, I would say the bottom half, or the bottom 2/3, are identical. That top third is almost like twice the density.
Yeah, yeah.
Yeah. Weird.
But it is managing to. It's almost completely managed to eliminate all of the dots. Look.
Yeah. Yeah.
You'd sit here for ages waiting for that one last dot to
Wait for the last
disappear.
pixel.
Each time it happens, it's going to be less and less and less. Oh, that one's gone. That one's gone.
Yeah.
Ooh, is it going to do? That one's gone as well. Oh yeah, not bad, not bad. Look. Yay! It managed it. Not bad. Not
Yeah.
bad at all. Yeah. All right. Okay, guys. Well, we are going to finish up then. We're going to finish up with that. And we'll say goodnight. And we will say, as always, look after yourselves, take care. And I was always happy coding. Good night. Bye bye.